Good morning students. Now I am teaching CBSE syllabus grade 10 chapter 1 real numbers exercise 1.2. Here what the first question, express each number as a product of its prime factor. Okay, factor or divisor same. So what is called divisor? When a number is divided by another number, the remainder is 0. The dividing number is called divisor or factor. So here the 140 we can write as product of prime factors. How we can write as? By using two methods are there. There are three method and division method. So here 140 we can write as like this. We can divide with prime factors, prime numbers. That is here 217 ja, 235 ja, 5 7 ja, 7 1 ja. 217 ja 140, 235 ja 70, 5 7 ja 35, 7 1 ja 7. So the 140 we can write as product of prime factor. These all are the divisors. These divisors nothing but factors. So the 140 we can write as 2 into 2 into 5 into 7. So the 140 we can write as product of prime factor. Here 2 is multiple how many times? 2 times. We can write as 2 square into 5 into 7. Next 156. So here we can divide with first least prime number, that is 2. Okay, here 2 2 7 ja, 2 8 ja, next 2 39 ja, next 3 13 ja, next 13 1 ja. So the 156 we can write as 2 into 2 into 3 into 13. 278 ja 156, 239 ja 78, 313 ja 39, 13 ja. Okay, here 2 is multiple how many times? 2 times. We can write as 2 square into 3 power 1 into 13 power 1. So the 156 we can write as product of prime factors. 3825. Here when I observe this number, its last digit is how much? 5. So a number which is its last digit is 5, it is divisible by 5. So here 3825 we can divide with 5. So 5 7 ja 35, 5 6 ja 30, 5 5 ja. Again we can divide with 5. 5 1 ja, 5 ja, 3 ja. Again here 3 5 ja, 3 1 ja. Next 3 1 ja 17 ja. Next 17 1 ja. So here we can write as 3825. We can write as 5 into 5 into 3 into 3 into 17. So 5 is multiple how many times? 2 times. You can write as 5 square. 3 is multiple how many times? 2 times. You can write as 3 square into 17 to the power of 1. So 3825 we can write as product of prime factors. Next 5005. So here its unit digit is 5. It is divisible by 5. So here 5005 is divided by 5. Here 5 1 ja 0 0 1 ja. So next 1001. So it is not divisible with 2. Why? Its unit digit is 1. It is divisible with 3 or not. Here 3 3 ja 9. Next 3 3 ja 9. Next it is not divisible. 11. Okay, next 5 not divisible. Next 7. 7. Here 7 1 ja 7. So here 7 1 ja 7. We can get remainder 3. We can draw 0. 30. 7 4 ja 28. Okay, next 30, from 30 we can subtract 28, we can get the remainder is 2, we can draw 1, 7 3 ja. Next here 11, 11 1 ja, 11 3 ja. Next 13 1 ja. So 5005 we can write as product of divisors, that is 5 into 7 into 11 into 13. 7429. Here the last digit is 9. So here it is not divisible with 2, it is not divisible with 3 because the sum of the digits is not a multiples of 3. It is not divisible with 5. Why? The last digit is 5. It is not divisible with 7. Okay, why? The last digit sum. The last digit 2 times is subtract from remaining digits. We cannot get as multiples of 7. It is not divisible with 11. Why? 7 plus 2, 9, 4 plus 9, 13. 9 minus 13, we can get as minus 4. So it is not divisible with. Next 13 also not divisible. Next 17. So 17 4 ja 68. Okay, we can draw how much? From 74 we can subtract 68, we can get as remainder is 6, 2, 7 3 ja 51. You can get the remainder is 11. draw 9, that is 7 7 ja. Next 19, 19 3 ja, 19 2 ja 38, 19 3 ja 57. So here 23 1. So 7 4 2 9. You can write as 17 into 19 into 23. Okay, these three are consecutive prime numbers. 17 is a prime number, 19 is a prime number, 23 is a prime number. So these three are consecutive prime number. Okay. Second one. Find the LCM and SCF of 60 and 20 by the prime factorization method. Okay. LCM means least common multiple. SCF means highest common factor. In which method? Prime factorization method. Okay, means the numbers are given. The given numbers we can write as prime factorization method. Means the given numbers we can write as product of prime numbers. Okay, first what are the given numbers? Here given numbers are 6 and 20. So 6 how we can write? 2 into 3. 6 we can write as prime factorization. 2 3 ja 3 1 ja. Next 20 how we can write? 2 10 ja 2 5 ja 5 1 ja. So 20 we can write as 2 into 2 into 5. Okay, this is the prime factorization. So now how we can take that SCF and LCM for this given two numbers by using prime factorization. Yeah, how we can take in SCF, how we can take the product of least common multiple of prime factors. In this two number prime factorization, what are the common prime factor? Two only common prime factor. So therefore 2 is HCF of 6 and 20. LCM means highest multiple of all prime factors. Here how many prime factors are there here? 3. What are there? 2, 3, 5. 2 is multiple how many times here? 2 times here, 1 time. So what is the highest multiple of 2? 2 into 2. 2 times of 2. Next 3 here 1 time. Here there is no times. So that is 3. Next 5. Okay. 2 2 ja 4. 4 3 ja 12. 12 5 ja 16. Okay. 60 is LCM of 6 and 20. Or we can take that another way. LCM. LCM means multiples of SCF. LCM is nothing but multiples of SCF. Okay. Find the SCF of 96 and 404 by the prime factorization method. Find their LCM. Here 96 2 48 ja 2 24 ja 2 12 ja 2 6 ja 2 3 ja 3 1 ja. So the 96 we can write as product of divisors. So 2 into 2 into 2 into 2 into 2 into 3. Next 404. So 2 202 ja 2 101 ja. So the 101 we cannot write as product of prime factors. Why? Because it is a prime number. It is a least 3-digit prime number. So here 101 1 ja. So 404 we can write as 2 into 2 into 101. So how we can take SCF in prime factorization? The product of least common multiple factor. Here 2 is multiple how many times? 5 times. Here 2 is multiple how many times? 2 times. So here what is the common prime factor? 2. Okay, here 5 times 2 is multiple. Here 2 times of 2 is multiple. So what is the least? 2 times of 2. So here the product of least common multiple factor 2 into 2, that is how much? 4. So 4 is HCF of 96 and 404. So here what asking that? Find their LCM. HCF of 96 404 is 4. They asking that LCM. So how we can find LCM? By using two numbers and SCF. Here we know that the product of two numbers is equal product of their LCM and SCF. So LCM of two numbers is equal product of two numbers by SCF of two numbers. So LCM of 96 404 is equal product of 96 into 404 by HCF of 96 and 404 how much? 4. So 4 1 ja 4 101 ja 96 into 101 ja. So how much you can get? 96 96. So LCM of 96 404 is 96 96. Find the SCF and LCM of 672 and 120 using a prime factorization method. Up to now, you can see that only two numbers. For the two numbers, you can find the SCF and LCM in prime factorization. Okay, now in this problem, they are given that three numbers. So here, how you can find same process. Okay, first 6, how you can write 2 3 ja 3 1 ja. Next 72, how you can write 2 36 ja 2 18 ja 2 9 ja 3 3 ja 3 1 ja. Next 120, 2 60 ja 2 30 ja 2 15 ja 3 5 ja 5 1 ja. Now 6 is equal to 2 into 3. 72 is equal to 2 into 2 into 2 into 3 into 3. 120 is equal 2 into 2 into 2 into 3 into 5. How we can take the SCF of the least common multiple prime factor? Here 2 is multiple how many times? 1 time. Here 2 is multiple how many times? 3 times. Here 2 is multiple how many times? 3 times. Okay, so what the least? 2. 1 time of 2. So HCF is 2. LCM is what? Multiples of SCF. So here what is the SCF? 2. Next. Okay. What the LCM? How we can take the in prime factorization? The highest multiple of all prime factor. Here 2 is multiple how many times? 1 time, 3 times, 3 times. So that is 3 times of 2. Next 3 here 1 time, here 2 times, here 1 time. What the highest? 2 times of 3. Next 5 here 1 time, here 0 times, here 0 times. That is 5. 2 2 ja 4, 4 2 ja 8, 8 3 ja 24, 24 3 ja 72, 72 5 ja 360. So the LCM of 6, 72 and 120 is how much? 360. SCF is how much? 2. Find LCM and SCF of the following by the prime factorization method. So 12, how you can write? 2 6 ja 2 3 ja 3 1 ja. 15, how you can write? 3 5 ja 5 1 ja. 21, how you can write? 3 7 ja 7 1 ja. So here 12 we can write as product of prime factors, that is 2 into 2 into 3. 15 we can write as 3 into 5. 21 we can write as 3 into 7. So HCF means what? The product of least multiple of all common prime factors. So in these three numbers prime factorization, what is the common prime factor? 3. 3. Okay, so the 3 is called HCF of 12, 15, 21. Next LCM means what? The product of highest multiple of all prime factors. Here how many prime factors are there? 2, 3, 5, 7. 2 is multiple how many times? 2 times. Here there is no times, here there is no times. Next 3. Here 1 time, 1 time, 1 time. Into 3. Next 5. Next 7. 2 2 ja 4. 4 3 ja 12. 12 5 ja 16. 67 ja 420. So 420 is LCM of 12, 15, 21. Next number 17, 23, 29. 17 how you can write? 17 into 1. 23 how you can write? 23 into 1. 29 how you can write? 29 into 1. Okay, these all are the prime numbers. So in this prime factorization, what is the common number? 1. Okay, so HCF is 1. Next, LCM is highest product of highest multiple of all prime factors. Here, 17 into 23 into 29. This product is become LCM of the three numbers. Okay, here 17 into 23, 21, 51, 34, 391 into 29, 9, 81, 35. Next 2, 18, 7. So 2, 9, 3, 13, 11. So here what is the LCM? 1, 1, 3, 3, 9. 8 how we can write? 2, 4 ja, 2, 2 ja, 2, 1 ja. 9 how we can write? 3, 3 ja, 3, 1 ja. 25 how we can write? 5, 5 ja, 5, 1 ja. So now 8 we can write as 2 into 2 into 2 into 1. 9 we can write as 3 into 3. 25 we can write as 5 into 5. After write the prime factorization, there is no common prime factors of the given three numbers prime factorization. So here there is no common prime factor. Let us take that is 1. So 1 is multiplied with anything we get the same. That is SCF is how much ma? 1. Next LCM is how much? The product of highest multiple of all prime factors. Here what are the prime factors here? 2, 3, 4. Okay, that is here 2 into 2 into 2. Next 3 into 3. Next 5 into 5. 2 2 ja 4. 4 2 ja 8. 8 3 ja 24. Okay, 24 3 ja 72. 72 5 ja 360. 365 ja 365 ja 0 3 0 18. So that is how much ma? 1800 is LCM of 8, 9 and 25. Find the LCM and SCF of the following pairs of integers and verify that LCM and SCF is equal product of two numbers. So first find that LCM and SCF. Okay, here how we can find either prime factors method or division method. Okay, here let us take by using prime factors method. So 26 how we can write 2 13 ja 13 1 ja. Next 91 how we can write 7 13 ja 13 1 ja. So 26 we can write as 2 into 13. 91 we can write as 7 into 13. So HCF. Here what is the HCF? Least multiple of common prime factor. In this two what is the common prime factor? 13. So here 13 is HCF. Next LCM is highest multiple of all prime factors. Here how many prime factors are there? Here 2, 7, 13. 2 into 7 into 13. 2 9 ja, no, 2 7 ja 14. 14 13 ja 14 13 ja. Here 52. 13 4 ja 52. 13 1 ja 13 plus 5 182. So the LCM is 182. Okay, the LCM of 26 and 91 is how much more? 182. So next, here what asking that verify that LCM into SCF is equal product of two numbers. So LCM is how much? 182. SF is how much? 13. Here LCM into HCF is equal product of two numbers. Product of two numbers. That is equal here 20. LCM is how much? 182 into SCF is how much? 13. Product of two numbers is 26 into 91. Okay, here these two numbers product 13 2 ja 26, 13 8 ja 104 plus 2 106. Here 13 1 ja 13 plus 10 23. Okay, so the product of two numbers is how much? 2366. Same here 1 6 ja 6, 2 ja 9 6 ja 54, 9 2 ja 18, 18 plus 5 23. So that is your 6 6 2 3. So product of two numbers is equal product of their LCM and HCF.